Hello guys, and welcome back to another video where I present you how we got to the theorem of solving second degree equations using the quadratic formula. So this is a proof. You don't have to know it, but it's really a good proof to know. So we start with, of course, what we know. We know that every second degree equation has the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a different from 0. As we said, if you have seen the last video, the example 2x squared plus 5x plus 1 equals 0, then our a here is 2, our b here is 5, and our c here is 1. So we saw that to find our solutions, we had the equation ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a different from 0. We calculate our delta equals b squared minus 4ac. If delta is negative, the equation has no real solutions. If delta, however, is positive, then our solutions are x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. And finally, if delta equals 0, then we have one double solution, x12 equals minus b over 2a. Now moving to the proof. Let a, b, and c be real numbers and a different from 0. Now in mathematics we should every time, maybe you have noticed, but we should every time uh, define what we have and what we don't have and our assumptions. Here a, b, and c are real numbers, as we said over and over again, and a must be different from 0. And let x be a real number that verifies our equation ax squared plus bx plus c. Our equation can be written as x squared plus b over a x plus c over a equals 0. We just divide it by x. Can we divide by divided by a? Sorry, can we divide by a? Sure we can, because as we said, a different from 0. We can never ever divide by a number that is equal to 0. We define then our delta, which is equal to b squared minus 4ac, which means that c over a, this c over a, is equal to b squared minus delta over 4a squared. Just took this equation. Let's try and write it. Let's use this. We have delta equals b squared minus 4ac. Sorry for that. Then 4ac equals b squared minus delta. We took this here, so the minus becomes plus here, and we took delta here, then the plus becomes minus here. So 4ac equals b squared minus delta. We divide by 4a in the left hand side and the right hand side. We get b squared minus delta over 4a. We have here c over a, so we're gonna look for c over a here. So if we divide by a, we get b squared minus delta over 4a squared. Good. Now we move to this part. Before moving to this part, we suppose that delta is positive, as we said in our assumptions while solving the equation. If delta is negative, then our equation has no solution. Now, if delta is positive, we have b over ax equals b over 2ax plus b over 2ax. It's like dividing by 2 and dividing by 2, and then by summing the two halves we get our b over a. And this is equal to minus b over 2ax minus b over 2ax. We multiplied by minus 1 here and by minus 1 here. So minus 1 times minus 1 times minus 1 gives us 1. And we did the same here. Then we added minus the square root of delta, and we added here the square root of delta. It's like adding minus 1 plus 1, which gonna gives us 0. So we typically did nothing here. We just write this in another form, which is this. So our equation becomes x squared equals minus b minus the square root of delta over 2ax minus b plus the square root of delta over 2ax plus b squared minus delta over 4a squared equals 0. This is what we found here. Our c over a equals this, and our b over ax equals this. So we factorize here by x in these two terms. So x multiplied by x, if we factorize here by x, we're gonna get x, and we factorize by x here, we're gonna get minus b minus the square root of delta over 2a. And we factorize here in these two terms by minus b plus the square root of delta over 2a. If we factorize by this term, we're gonna get x here, and we're gonna get minus b minus the square root of delta over 2a here. If we are wondering where did we got this term from, we're gonna do the opposite of what we did here. We're gonna do the opposite. So if we take this term here, which is minus b plus the square root of delta over 2a multiplied by x minus b minus the square root of delta over 2a, we're gonna get minus b plus the square root of delta over 2ax, which is this first term, plus b plus the square root of delta over 2a times b minus the square root of delta over 2a. And this, it's gonna use this, and this is of the form x plus y times x minus y, which is equal to x squared minus y squared. Sorry for the colors, the red and the blue. So we got b squared plus b squared. B is our x and the square root of delta is our y. So we got b squared, which is equal to our x squared, minus the square root of delta squared, which gonna gives us delta. And 2a times 2a gives us 4a squared. So as we said, we got this equation: x times x minus b minus the square root of delta over 2a minus b plus the square root of delta over 2a times x minus b minus the square root of delta over 2a equals 0. If we look carefully, we're gonna see that these terms are similar. So we're gonna factorize again and get x minus b plus the square root of delta over 2a times x minus b minus the square root of delta over 2a equals 0. And finally, if you know your homework well, if you've done your homework well, you know if we have the product of two terms equals 0, then the first term must be equal to 0 or the second term must be equal to 0, which means that x equals minus b, sorry, we have a minus here and we have a minus here. So x must be equal to minus b minus the square root of delta over 2a, or x equals minus b plus the square root of delta over 2a, and hence we got the proof of the quadratic of solving second degree equations using the quadratic formula. I hope you enjoyed and you learned from this video, and until next time.